Hello, friends. Welcome to lecture number 13. And in our last few lectures, I told you you can supply the equation to draw a circle and ellipse, but we explored further, and there exists beautiful comments to draw. For example, for a circle, you just say circle, type circle, and in the bracket you write the coordinate of the center and the radius. Circle will be drawn. Similarly, for the ellipse, the properties are different from circles. If you specify two foci and a point, then this ellipse will be uniquely defined, which also can be drawn by writing a comment. Then we told you how to verify the property of an ellipse, that is, the distance from the foci, sum of the distances from the two foci of a particular point is always a constant, no matter where the point P exists. So, carrying on with this, I am going to tell you um, about uh, parabola today. For example, parabola, we know how to write down the equation. Parabola will be drawn, but we will do it in a different way. For a parabola, as you know, there exists only one focus and another line, important line, that is called a directrix. And the property of any point P on the parabola is this, that the perpendicular distance of this point P from the directrix line will be same as the distance from the point P and the focus. Therefore, it looks like if you specify a point, the focus and the directrix, then the parabola will be uniquely defined. So that is what we do. Suppose we write the coordinate of the focus to be, say, 2 comma 0. uh, we write that this is the focus of the parabola going to be. Then we write down the equation of the directrix, which is known to be x equal to, say, minus 2 comma 0. So this is done. Oh, I'm so sorry. Why it is drawing a vector? Is another equation of the line is x equal to simply minus 2. So this is the directrix, this is the focus. Then once these two are known, you can draw a parabola just by typing this parabola. You need not remember, you just simply write a few lines about parabola, and then there are options, as you can see, a point and a line. That is this option I'll choose, and in the point means it is the focus, and the line means it is equation 1. Is that clear? Equation 1, and the parabola is drawn, is not? Now what will be the next step? To just verify that any point P, if you take on the parabola and this distance, suppose PS, and drop a perpendicular from P on this equation of the directrix, that is the straight line directrix, these two should be equal no matter where the point is. That is, I want to do now. So I take a point here on the uh, parabola, that is P is equal to a point on what? On the parabola, that is C. The name of the parabola is C, the object name. So point P is on C. And you see it has drawn a point, and this point will be always confined to the parabola, and that is what we have seen. Now what we want to do is this point. I will take this length and this length, so I have to drop a perpendicular from this point P on this green directrix line. So how to draw that? So that too can be drawn by writing like this perpendicular line. You choose perpendicular line, and then you choose this, that is perpendicular line from the point P, and which line on the directrix line, that is named as EQ1. So you write EQ1, and it has drawn a perpendicular line, is not? Then you see that is fine. But I am interested to find out the point of intersection here. Then the point of intersection of this line with this directrix I want to locate, and I want to say that intersect. Oh, sorry, here I have to do intersect. Here I write, it is not coming. You just remove this here, right here. Intersect, intersect, intersect between two objects. I select, and one object is this safe, and the other object is equi1. This point I want to pinpoint there. So f comma equi1, equi1, and this point appears here and given a name A. Is that clear? And that is this. Now I will be, this is point P, so I will be now interested to uh, find out the line segment PA and PS. Okay, so find out the line if you can delete. Okay, and then I say that okay, you write segment line segment, that is P comma A, that is good, and then the line segment PS. So I do that segment P comma S, P comma S. This is the thing. And you return it. So this length is H and this length is G. The value of this is 4.57, 4.57 something. Now the interesting point is if you now move P, and P I have restricted its movement on this parabolic graph, so move it anywhere you like. You see PA, that is G and H, they are always equal, no matter where P is. Is that clear? So it shows, brings out that nice property of a parabola in this particular fashion. So in this example, I have drawn a parabola in a different way, not writing down the equation. In a parabola, if you uh, know its focus, and if you know the perpendicular distance of any point on a particular line, say directrix, which is eq1 in this case. These two are equal. Therefore, if you supply these two, then the parabola will be uniquely defined, and that is what we did here to draw the parabola. Parabola focus, which I have defined earlier. I have defined the directrix, and the parabola is uniquely defined. Then I took a general point on the parabola P as usual. Then I drew a perpendicular from P on this. So there are a lot of instructions you can learn. And I am telling you repeatedly, the instructions are, you don't have to remember. You just type few lines, several options comes, and you can yourself decide which option to be used for that. So that's fine. Now, now what I will do is this. I will clear all my board. Now the last conic section or the curve which is interesting is an hyperbola. Okay, you can write down the equation of an hyperbola and like an ellipse, circle, parabola. That is the usual way to write it. If you know the equation, you write it. That will be faithfully drawn. But here I will do it in a slightly different way as I have done for ellipse and parabola. That is what is the unique property of any point on a parabola, on a hyperbola. I'm so sorry, hyperbola I'm talking about now. Hyperbola 2 has two foci, okay, and any point on this hyperbola, if you take the distances of that point separately, if you calculate the distance of the first foci and the distance of the second foci from the same point P, uh, the difference of these two will be constant. In case of ellipse, any point P on the ellipse, the sum of the distances of that point from the two foci, these two are equal. But in case of hyperbola, a general point P, if it is lying on an hyperbola, and if you know its foci at S1 and S2, then PS1 will give you one length, PS2 will give you another length, and the difference of these two will be invariant no matter where the point P lies. That is the thing I want to demonstrate in case of hyperbola as well. So first I define two foci is arbitrarily -1, comma 0. This is suppose foci 1, and I will just name of the point I will give S1. No, S1 equal to, you write, it is the first foci it has drawn. Okay, you draw the second foci, that is S2 is equal to say at 1 comma 0 equal to, I have to place because two variable names I'm giving. Okay, so this is S1 and S2 are the two foci I've drawn. Then you take any point you like. For example, P. Now, like ellipse, if you just simply define the foci, there may be infinite number of parabolas you can draw. That is defining the foci of hyperbola. You cannot get a unique hyperbola. Okay, so I have to give a point apart from these two S1, S2, as we did in case of an ellipse. So I write P is any point, say -3, comma 4 you give a point P ellipse. What I'm telling, these 3 points will uniquely define an hyperbola. So let us write the command. So hyperbola. What are the things I have to supply? The two foci, that is S1, comma S2, comma this point P. And if you do, your hyperbola is there. And as I told you, this P could be anywhere. If you change P now, you will get different parabolas. But for a particular value of P and S1, S2, I have already fixed up. So these three will together make a hyperbola unique. Got the point? So suppose this is the thing for a given point P I have done. Now the third thing what I am going to do on this hyperbola, uh, I have to define a point which will be restricted on this hyperbola only. Okay, so how to do that? Take any point, say Q, take any point Q on the hyperbola that is equal to point P-O-I-N-T, point where on the hyperbola which is named C here, so write C and you get this point Q. Now on this hyperbola, if you move Q, you can easily see it will never leave this hyperbola, this one. How to go to this side? Come this one, it goes. In between the Q does not exist, so it has got a jump. Intelligently, it will jump and it will give you any point on the hyperbola. Now this name I will just move a bit here. This name I'll move a bit here. So S1, S2 are the focus. Now this QS1, this length and these two lengths are not equal, and hyperbola means that if you take the length of this segment QS1 and QS2, and if you take the difference of these two lengths, that should be independent of the fact where Q is placed. So that is what I am going to do next here. So I say that segment, okay, Q comma S1. I do that. Then I do the segment, same thing, segment Q comma S2. Okay, this is the thing. Okay, okay, you know can vary Q. Your both F and G will change. But what I am telling is this: the difference of these two lengths, that is absolute value, because if here you find this length is shorter, this length F is shorter than G, but if it goes there, uh, F will be longer, G will be shorter, G is this length, and so take the absolute of the difference, so absolute uh, uh, of what F minus G, this length you take, it is 1.142 something. Now we expect that no matter where Q is, you vary Q, You see, this A is not changing, although F and G are changing. No matter where this Q is lying. Come here, there, go anywhere you like on this hyperbola. Is it not a very nice way to verify the properties of various conic sections like circle, hyperbola, parabola, things like that? And by drawing these things, you also come to learn about very useful and simple instructions what to write here. Don't get frightened or agitated. You have to simply write two, three words about the thing what you want to do. Hyperbola, you just type. It will give you several options. One of the options I have chosen, okay, two foci are fixed and then a third point, like that. Hope you please go through that. I stop here. Hope you have enjoyed this lecture. And from my next lecture, I will tell you some newer things. Thank you so much for viewing this. See you next time in lecture number 14.